In this video, we're going to bring together some of the ideas we learned from probability and also in the past couple videos with counting techniques, or as I call them, speed counting. So we can use counting techniques to find the total number of outcomes we want to happen, which with probability, that's the value that goes in our numerator, and also to find the total number of possible outcomes that are available entirely, which is the value that goes in our denominator. So example 12, part A here, we have a combination lock has 3 dials with 10 digits each. What is the probability of guessing the combination on the first attempt? So I've actually done this before, believe it or not. Happened when I was in middle school, I think. But the total number of possible outcomes in our denominator, we have 10 digits available for the first number in the lock combination, 10 for the second, and 10 for the third. So we're allowed to repeat the numbers, like 113 would be okay. So our total for our denominator, 10 times 10 times 10, is there's 1,000 different possible combinations you can make on a 3-dial lock with 10 digits each from 0 to 9. Total number of outcomes we want is 1. There's only one combination that's going to open this lock. So one number out of the 1,000 is our chance that we guess it correctly. So not a very high chance, but it could happen. And it has. Example 12, part B. What is the probability of the previous example of each of the digits must be unique? So now we can't have 10 times 10 times 10 because as soon as we get rid of one digit, we can't use it again. So now our total number of possible outcomes in our denominator is 10p3. So 10 times 9 times 8, or 10p3. We still only have one number that's going to work, so we only have one value in the numerator. So now our probability is 1 out of 720. So our chances of guessing correctly actually did go up because 1 out of 1,000, our first one, is less than 1 out of 720. So that's, in this case, it's less secure if you're not allowed to repeat the digits. So. All right, example 13. In a state lottery, you pick 6 numbers from a possible 49 numbers and win a prize if you match at least 4 of the 6 numbers. So if you get 4 or 5 or 6 numbers correct, you win. So what is the probability of matching 4 out of the 6? So what's the bare minimum chance of winning here? Well, the total number of possible outcomes in the denominator is 49c6. And I always like to find the denominator first because it's easier for me, and but it doesn't really matter if you find numerator first or denominator. But out of the 49 possible numbers, we want to group them in a group of 6. And since the order in which you pick your lottery numbers doesn't matter, this is a combinations problem, as most lotteries tend to be. Now, for the total number of outcomes we want in the numerator, we have to break this down into 2 separate events. So we want to know, out of the 6 winning numbers, we want to pick 4 of them. So how many different ways are there of selecting 4 winning numbers from 6? Well, there's 6C4 for that. So out of the 6 winning numbers, we want 4 of them because, again, we're just matching 4 out of the 6. We're seeing what's the bare minimum for this. So 6C4. Now, since we picked the 6 numbers now, those 6 numbers been drawn, there's actually 43 numbers left to choose from. So 49 minus this 6 gives us 43. And we've already picked 4 numbers. We need to pick now 2 losing numbers from 43. So the number of ways to select 2 losing numbers out of 43 numbers is 43C2. So again, there's 6 winning numbers. We want 4 of those 6 winning numbers, so 6C4. And then for the rest of our numbers that didn't win, there's 2 of the numbers that didn't win. And since 49 numbers were in the hopper or whatever it is, they take out 6 of them. That means 43 of them are losing numbers. We want 2 out of those 43 losing numbers, or 43C2. So our probability can be found by taking 6C4 times 43C2 and then divided by 49C6. Which I would just put all this into a calculator. You get about 0.097%. So about a 0.01% chance of winning 4 out of 6. Part B, what is the probability of getting a losing lottery ticket? So in this case, you're going to have a losing ticket if you match 3 numbers or less. So if you got 0 matches, 1 match, 2 match, or 3 matches, you're not going to win. And since we already calculated the probability of getting 4 matches, we can continue up to 6 matches. So we'll calculate 5 and then we'll calculate 6. And then we can use our complement rule from probability to find the chance of that happening. So the probability of getting a losing ticket is 1 minus the probability of a winning ticket. So you get a winning ticket if you have 4 matches or 5 matches or 6 matches, which these are mutually exclusive events. You can't get 4 and 5. You can't get 5 and 6. So recall that for probability of mutually exclusive events, when we separate them by the word or, we just add their individual probabilities because we don't have to worry about getting a ticket that has both 4 and 5 matches on it. So we want to calculate the probability of 4 matches, add it to the probability of 5 matches. Well, we already did the 4 matches. And then add it to the probability of 6 matches, and then subtract that total from 1. So probability of 4 we calculated in the last problem. 5, it's going to be 6C5 because we get 5 numbers out of the 6, and then now we have 1 loser out of the 43 losers. And then notice our denominator is still the same. And then for 6, we picked all 6. We didn't pick any losing numbers. And then out of the total ways there are of picking those, and 1 minus the probability of picking 4 plus the probability of 5 plus the probability of 6. It's about a 99.9% chance of purchasing a losing ticket. So as you can see, it's not exactly a wise move to try to get rich playing the lottery. So be careful, because you see multi-million-dollar prizes, but calculating your chances of losing, you have a very, very high chance of not winning a single thing. So, and again, if you get 4 numbers right, you're not going to get nearly close to what the jackpot is. So you want to be careful with that stuff, because it could lead to a lot of financial problems for you down the road, and you don't want that to happen. I don't want that to happen to you either. So all right, but that about does it for this video. Thank you for watching. I'll see you next time.